Welcome back, everyone, to the Deep Dive. This time, we're going to be taking a look at AI co-scientists. Sounds pretty futuristic, right?
It does, and it is, but we're breaking down a couple articles from Google Research and ZDNet that get into how it all works.
Exactly. And I think a lot of people hear AI and they think of, robots taking over the world.
Right, or like writing poems or composing music.
But this is something else entirely. It's AI designed to help scientists, like a superpowered research assistant.
Yeah, it's being called an AI co-scientist, and I think that's a pretty fitting name, especially the one Google's developed based on their Gemini 2.0 model.
Oh, so this is actually a real thing. It's not just like a concept.
Oh yeah, it's definitely real. And the cool thing is you don't need to be a computer whiz to work with it.
So how does it actually work? Like, can I just talk to it?
Well, yeah, kind of. It uses natural language processing so you can actually communicate with it like you would with a person.
Wow, so I could say, like, hey, AI, find me a cure for cancer, and it would just, like, get to work.
It's not quite that simple, but you're on the right track. AI can read and understand scientific papers, tons of them. It can sift through all that information and pull out the key findings.
That's incredible. I mean, just imagine how much time that would save researchers.
Right. It's like having a research assistant who can read thousands of pages in a day and then tell you exactly what's important.
So it's a speed reader, but can it actually come up with new ideas? Like, can it think for itself?
Yeah, actually, it can. It's not just one program. It's a whole bunch of specialized AI agents working together, kind of like a team of scientists.
Whoa, AI agents. That sounds like something out of a movie.
It does, right. So
Yeah.
there's one called a generation agent, which comes up with initial research directions, kind of like brainstorming.
Okay, so it's got the ideas, but what then?
Well, then the reflection agent steps in. It's like the critical thinker. It checks those ideas, sees if they hold up.
How does it do that? Like, fact-checking on the internet.
That and more. It does web searches, runs simulations, even does these AI-powered peer reviews.
Whoa, so it's like a super-powered fact-checker. But how do we know which ideas are actually good?
Well, that's where the ranking agent comes in. It actually scores each hypothesis, kind of like a chess ranking, ELO scores.
Oh, so it's like a competition, with the best ideas rising to the top.
Exactly. And then we've got the evolution agent. This one takes the top-ranked ideas and refines them even further.
So it's like polishing those diamonds in the rough.
Yeah, great analogy, but we can't forget the proximity agent. This one makes sure everything stays focused on the original goal, like a project manager.
Oh, that's important. Keeps everything on track, right?
Yep. All these AI agents working together, that's what makes this co-scientist so powerful.
So it's like a dream team of AI researchers. But if the AI is doing all this, what are the human scientists doing?
That's a really important point. It's not about replacing scientists, it's about giving them this incredible tool to work with.
So it's more like collaboration then.
Definitely. It's about having a human in the loop, Scientists are still guiding the AI, making sure it's on the right track.
It's like giving scientists superpowers, boosting their own abilities and making discoveries faster.
Exactly. And the cool thing is, it's already making a difference. There was this study where the AI actually outperformed other AI models and even some human experts in solving certain scientific problems.
Whoa, really? Outperform human experts? Like what?
Well, in one study, it was able to predict potential drug candidates for leukemia. It looked at all these different molecules and actually identified ones that could be effective.
Wow, so it's not just theory, it's actually helping find real treatments for diseases.
Right. And in another study, it was used to research liver fibrosis, and it actually found these epigenetic targets that could have antifibrotic properties.
Okay, so I'm not a scientist, but even I can see how big of a deal this is. It's like having a superpowered research assistant working around the clock to find solutions for these really tough medical problems.
Exactly. And it's all happening in collaboration with scientists. It's not about replacing human expertise, it's about augmenting it, giving scientists this amazing new tool to work with.
That's a really powerful idea. But how does it get so smart? Like, how does it learn to think like a scientist?
Well, there's this concept called test time scaling, and it's one of the reasons this AI co-scientist is so powerful.
Test time scaling. That sounds, complicated.
It's actually simpler than it sounds. Think about learning to play an instrument. The more you practice, the better you get, right?
Makes sense, yeah.
So it's kind of like practice for the AI. The more it works, the more computing power it uses, and that helps it get better at reasoning and problem solving.
So it's like building mental muscles as it goes.
Exactly. And the more it works, the sharper it gets. ZDNet even called it test time scaling on steroids.
On steroids. Wow, so how is this different from other AIs that use test time scaling?
Well, other systems, like DeepSeek's R1 model, usually focus on one specific task. But this AI co-scientist is like a whole team of experts, each getting smarter, thanks to this test time scaling.
It's like having a whole research department packed into one AI system. But if it's constantly getting smarter, is there a limit to how smart it can get?
That's a great question, and honestly, we're still figuring that out. But the potential seems pretty huge.
I mean, it makes you wonder what the future of research will look like with these AI co-scientists by our side.
It's exciting to think about, right? It
Yeah.
really is exciting. I mean, imagine the possibilities, if this AI can help scientists make these huge discoveries so much faster.
Right. It makes you wonder, like, what else is out there hidden in all this data that we just haven't been able to see?
That's exactly it. These AI co-scientists can look at massive amounts of data, way more than any human could ever handle.
It's like having, what's the word? Like a superpowered detective for science.
Ah, I like that. And it's not just about crunching numbers. These AIs are designed to think like scientists, to come up with hypotheses, even design experiments.
You know, we talked about that test time scaling, how the AI gets smarter as it works. But is there, like, a limit to how smart it can get?
That's a good question. To be honest, we don't really know yet. But it seems like the potential is, well, pretty enormous.
So the more it learns, the faster it learns.
Eh.
Kind of like a snowball effect.
Yeah, exactly. Plus, it's not learning in a vacuum. It's working with human scientists, getting feedback, constantly
I
improving.
think a constant back and forth learning from each other.
That's right. And remember that ZDNet article? They called it test time scaling on steroids. But do you think maybe this rapid advancement, could it be, a little too fast?
That's a good point. I mean, can we really keep up with it? What about the ethical side of things?
No, absolutely. That's a huge concern. We need to make sure that as this technology gets more powerful, we're using it responsibly.
So safeguards, checks and balances, that kind of thing.
Exactly. Transparency and accountability are going to be crucial. We need to understand how these AI systems are making decisions.
And make sure those decisions align with, our values as humans.
Right. And, we've talked a lot about medical breakthroughs, but what about other fields? Where else could these AI co-scientists make a difference?
I mean, the possibilities seem endless, right?
They really do. Imagine them working with climate scientists, helping us understand and tackle climate change, maybe even design better energy sources.
Wow, it's like giving a boost to every field of research.
Exactly. It's not just about solving problems either. It's about making new discoveries, maybe even ones we haven't even thought of yet.
Oh, what if an AI helped us discover a new law of physics? Or like a new element?
It's definitely possible. AI could help us see the world in totally new ways, uncover things that our human minds just wouldn't be able to grasp.
It's like we're on the verge of this whole new era of scientific discoveries. But are there any challenges we need to be aware of?
Oh, definitely. One big one is accessibility. We need to make sure this technology is available to researchers everywhere, not just a select few.
Right. It can't just be for the elite institutions. It needs to be for everyone.
Exactly. Another challenge is making sure these AI co-scientists are actually good collaborators. We need to figure out how to communicate with them effectively.
So it's not just about the tech. It's about the relationship, the partnership.
That's it. And we need to be careful about the impact on scientists themselves. We don't want to replace them, just empower them.
It's about finding that balance, right? Using AI to its full potential, but not forgetting the human element.
Exactly. It's about partnership, not replacement.
So where do we go from here? I mean, what's next for AI co-scientists?
Well, I think that's where things get really interesting.
Okay, so before we get into that, I want to go back to something you said earlier.
Oh,
About what?
you mentioned that AI co-scientists could make discoveries we haven't even imagined yet. I'm really curious, what are some areas where that might happen? That's a tough one. But I think one area that's ripe for exploration is the study of consciousness. We still don't really understand what it is or how it works.
Right, it's like one of the biggest mysteries of, well, existence.
Exactly. And it's a really hard problem to tackle with traditional science. But AI, with its ability to analyze tons of data and find those hidden connections, could be the key.
So it could help us understand what makes us, well, us. That's pretty profound.
It really is. And there's so many other areas too, like the origins of the universe, the search for extraterrestrial life, maybe even developing new materials with properties we can't even fathom right now.
It's like we're standing on the edge of this vast unexplored frontier, and AI is giving us the tools to map it.
That's a great way to put it. It's an incredible time to be alive, to see these advancements happening in AI and science. But we need to remember to do it responsibly.
Right. Ethics first.
Yeah.
We're not just developing technology, we're shaping the future.
Yeah.
And that's a huge responsibility.
I agree. And I think that's a good place to take a break. It's been a really interesting conversation, lots to think about.
For sure. We've talked about the potential of AI co-scientists, the challenges, the ethical considerations. It's a lot to take in.
It is. And we've only just scratched the surface.
Well, when we come back, we'll dive into some more specific examples of how AI co-scientists are being used, and maybe even speculate a little about what the future holds. Welcome back to the Deep Dive. We've been talking about these amazing AI co-scientists, and I'm really excited to see how they're actually being used.
Yeah, we've talked a lot about the theory, but now let's get into some real-world examples.
Perfect. So where do we start? What fields are seeing the biggest impact?
Well, healthcare is definitely one area where AI co-scientists are making huge strides.
You mentioned earlier that one was able to predict potential drug candidates for leukemia.
Right. It looked at this massive database of molecules and, get this, actually found promising candidates that human researchers had missed.
Wow, that's incredible. It's like finding a needle in a haystack, but the needle is a life-saving drug.
Exactly. And the AI did it faster and more efficiently than humans ever could.
So this is really happening. It's not just sci-fi anymore. AI is actually helping develop new treatments.
Oh, absolutely. And it goes beyond just drug discovery. AI co-scientists can help us understand diseases better, find new targets for therapies, even personalize treatments based on someone's genes.
Wow, that's amazing. It's like medicine is becoming so much more precise, more effective because of AI.
That's the idea. And it's not just limited to healthcare either. AI co-scientists are making a big impact in materials science, too.
Oh yeah, like how?
Well, imagine materials that are lighter than steel but stronger than diamond, or materials that can conduct electricity with no resistance.
Okay, now that sounds like sci-fi.
I know, right? But these are the kinds of things AI car-scientists are helping us explore. They can analyze existing materials, simulate new combinations, and guide researchers in creating materials with unbelievable properties.
So what, we're gonna have flying cars soon?
Maybe, haha. But seriously, the applications are huge. Lighter, stronger materials for planes, more efficient solar panels, even biocompatible materials for implants and prosthetics.
It's like the possibilities are endless. So AI co-scientists are good for healthcare, material science. What else?
Well, they're also making a difference in climate science, helping researchers analyze climate data, identify trends, and create better models to predict and hopefully mitigate climate change.
So they're tackling some of the biggest challenges facing humanity. What about economics? Can AI co-scientists help there too?
Definitely. They can analyze economic data, identify market trends, and make more accurate forecasts. This can help businesses make smarter decisions and governments create better economic policies.
Wow, it seems like AI co-scientists are becoming essential in so many fields.
They really are. And as the technology keeps developing, we can only imagine what new applications will emerge. It's an exciting time to be following this AI revolution.
It really is. This has been such a fascinating deep dive. We've gone from the basics of what an AI co-scientist is to seeing the real impact they're having on research in the world around us.
It's been a great conversation. Lots to think about.
Definitely. And as we wrap up today's episode, I want to leave our listeners with one final thought. If you had an AI co-scientist working alongside you, what discovery would you want to make? It's something to ponder, for sure. Thanks for joining us on the Deep Dive.